Science. Technology. Medicine. Health. These four things make the world go round. Without them, we couldn't exist. This is the Monday Science Podcast, a weekly show bringing you the latest research and news in science, technology, medicine, and health, answering your questions or finding experts in the field to answer them. Your host is a pharmacist, an award-winning scientist. She leads her own research group and is the founder of King's College London Fight the Fakes. A tad bit on the qualified side. Welcome to Monday Science. Here's your host, Dr. Bahija Raimi Abraham.
So how has COVID-19 been, because I know we talked a little bit earlier about you pivoting your research, but I just mean for you as a scientist, because I know how it's been for me. How has it been for you managing your lab, or maybe not having been able to manage your lab during the pandemic?
Yeah, it was tough. We have to reduce the density of people. My lab, it's a very lively lab. We have lots of people. It's very crowded, and everybody's working at the same time. And of course, when COVID hit, we have to reduce that. So we were allowed to continue the research only partially, mainly because we start actually researching the consequences of the coronavirus in the brain. My lab has experience on understanding the impact of viruses in the brain. And so that's how we got the lab up and running, partially because of this kind of research. But of course, we are only now revamping the research and people are allowed to come back. So we lost lots of grants. We couldn't apply for many grants or renew some of the grants. So definitely we kind of shrink a little bit, but hopefully we will be able to restart again. So most of the research that were not COVID related was on pause. So it's a bump, but that's life. I think we are in the same page.
Yes, definitely. I think for me with COVID, I was so anxious about my team. My team is not large, but we're effective, and you feel as a group leader, you feel such a sense of responsibility that you don't want them to be endangered, as well as, you don't want anybody to be endangered. But it was sort of my fears initially was, okay, what's the WHO saying? I don't really know what's anyone saying. Everybody get out. At some point I just made my executive decision. It's like nobody's in the lab. And then of course, the impact that has on PhD researchers in particular, who are working towards their goal of getting their PhD, and to have everything at a pause. But I think it's really good that you were able to contribute with your work and from previous experience with viruses and things like that. And yes, the other thing of grants and papers and all that, but I feel like we're all trying to get ourselves back. I would say one of the good things to some extent is people have seen, one of the reasons why I personally like research is I like the global element of research. I like the fact that you to collaborate with the person who is specialist at your field. They may be in America, they may be all over the world, so you then don't think within the limit of where you are. And that's one of my main reasons for loving science in general, is just the global element. And I do feel that one of the things with the pandemic, it has opened up the world more in terms of science, because we all need to talk to each other to get some insight and understanding. And I feel people are a little bit more receptive to communication now across various parts of the world, because you can communicate a lot easier via video call, which was there before, but somehow I don't know, things have changed.
No, I'm with you. I think there are positive lessons that we're taking that, and I hope that the community would implement. I was used to do these travels, take like 1 or 2 days to get to the place, give 1 hour talk, and that's it, come back the next day. I see no point again to continue to do that. We actually, in our program here, we incorporate like the video talks, the Zoom, and we have easily like 300 people, whereas in the past in live was like 90 or 80. So we can definitely increase the audience.
Definitely. And I have to say, I'm similar to you. One of my favorite parts of research was going on conferences, networking, and, finding out what other people are doing. But now that you can do things virtually, it also means that people all over the world can actually access
Right.
the information that, the people's research. And I think you're right as well, from 90 to 300 to 500 capacity. It's really good. But I wanted to talk about your temporary pivoting into, well, it's not really into, because you were clearly obviously doing some work previously on viruses and the effects in the brain. So looking at specifically the influence of SARS-CoV-2 coronavirus, what did you find out? Could you just give us some insight into your key findings? And I know you were also looking at how the drugs performed as well. So yeah, just let us know what you found out, please.
Yeah, so it was kind of not clear, but we have a hint in the beginning. Now it's clear that COVID has a neurological component. And the question is how that happened. I mean, if it's, do the virus cross the blood-brain barrier? Can the virus reach the brain? And so we have those fundamental questions. And the questions we had is, can the virus actually infect neurons or glia cells or other brain cells? So what we did was to expose some of the brain organoids to the SARS-CoV-2 and see if they can infect the cells and make any damage to these organoids. And what we find out is that, yeah, most of the cells, there are some exceptions, do get infected by the SARS-CoV-2. It's not a huge infection, but they do express the receptor. The virus can get in and replicate. And then we see some interesting things. We see that some cells die. We see some inflammatory responses coming from the glia cells. And we also see, and I think that's the most dramatic thing that we notice, a decrease in the number of excitatory synapses in the cortex. So these might explain why some people have these hallucinations or fatigue or I mean, these long-term consequences. It might all be down to this dysregulation of the cortical synapses. And this happens like 48 hours after you expose the virus to the neurons. So it's really fast. Also, another thing that we noticed was not only in the cells that receive the virus. We see sometimes the effect in other regions of the organoid with no viruses. So that suggests that there is a bystander effect. There are some whatever tropic factors or cytokines that the virus are causing into these cells can travel to other brain regions and also cause damage there. So that's the bad news. The good news is that we can use the system to try drugs or screen drugs that might revert those problems. And we were able to find one antiviral that is approved for hepatitis. It's called sofosbuvir from Gilead. And that is able to cross the blood-brain barrier, and we can block the viral replication in the brain cells and restore the synaptogenesis. So I think that's a good news. So hopefully these would be adopted in clinics later on.
With Corona, because the research had to come out so quickly, because everybody was, I don't want to say maybe there was a competitive element, but how did you find that, just from, trying to make sure that you're doing something with, research integrity and so forth, but then getting the information out there? Because not just so much because you necessarily want to be the first person to talk about it, but because nobody knew or had any insight to what's going on. So anything that you're finding is going to greatly contribute and have a positive impact to help us understand what's going on.
Yeah, and I discussed that with my lab, and that's exactly the message that I try to convey. I said, I don't care if I'm the first or not. As soon as we have some data, let's deposit on bioRxiv, and that's what we did. And we continue to work on that to make sure that, the research is correct. I was so afraid of reporting something that might be wrong later on, just because of the speed. And my posture was, no, let's not do that. Let's just take our time to do it. Even if we're not the first ones to publish, at least we get it right.
Yeah, research integrity has been a big thing. And also, I say, I'm just using the blanket term research integrity because I don't believe that people who published their work and it had to be retracted, I don't necessarily believe there was an ill intent, because I think it was just, everybody was so desperate just to have an understanding of the effects of the virus. So maybe there wasn't due diligence and everything, and it's really quite inspiring to hear you say that, no, we're just going to do it right, and be as accurate as we can be, and not necessarily the first, which is really powerful.
And I mean, I own that to my lab, because to me, I mean, really publication or more would not make a difference in my career, but for my postdocs and grad students, I was worried about them.
Yes.
And they said, no, we agree, we are with you, we understand this is bigger, and it's a unique moment in human history, and we are part of that, so we want to have a positive contribution. So I mean, they are fantastic. I love my team.
It's so nice to hear you say that, because we really like having a team. The research group is your name, is you, but it's also a team. And I think people don't realize that all the time, that you have to acknowledge the work that your team do, because they are the ones that also help, because without them, there isn't anything. So that's, I mean, I think that's really important. With the COVID-19 infection and the effects on the brain, did you find any potential or any data that would suggest long-term effects, like you've explained sort of with the cells that may have died and close by? So what are the potential long-term effects?
Yeah, so I think this observation of the reduction of the synapses, I think that it is reversible, by the way. We see that being reverted slowly. We don't know how long does it take, because we haven't not performed like long-term experiments yet. But I think that's a possibility. So it actually goes well with the clinics, suggesting that, yeah, for some people, and by the way, I think this might be related to the load of the virus that actually gets into the brain. Some people really show this long-term effect of the coronaviruses. But the good news is that it's revertible, and I think we have a way to treat that.
Stress, I know they found like stress and how that affects people's bodies has had an impact in people's, I don't want to say response, but also how they've coped with COVID or post-COVID or long COVID over time. So it's very interesting. And so you mentioned with the drug that so did you say it was an antiretroviral or anti-inflammatory?
Antiviral.
Antiviral.
Sofosbuvir, yeah.
Okay, and so did you say that's already in clinical trials, or there's work being investigated?
I don't know. I think there are some clinical trials going on. As soon as we put our paper in bioRxiv, several people contacted me, but I'm not following it. I don't know.
Nice. Okay, well, thank you so much.
You've been listening to the Monday Science Podcast, a weekly show bringing you the latest research and news in science, technology, medicine, and health. We hope you've gotten some useful and thought-provoking info from the show, and we hope you had fun along the way. We know we did. We'll be back soon. But in the meantime, hook up with us on our website at www.mondaysciencepodcast.com. Shoot us an email at info@mondaysciencepodcast.com. Find us on Instagram, LinkedIn, and YouTube at Monday Science, and access episode summaries at mondayscience.medium.com. See you next week on the Monday Science Podcast.